Hello there, my name's Vince from My Mate Vince, and in this video today I'm going to be looking at not 1, not 2, not 3, but 4 Xbox Series X fridges. Yes, you probably thought they looked a little bit big. They are fridges. So, yeah, I bought them off eBay for £13.50 each, which I didn't think was too bad, because often they can sell for £60, £70, £80. So, yeah, although they are big lumps of plastic junk looking like things, obviously there must be a bit of a market for it. And I kind of get that, because as soon as my son seen these, he was like, I want one in my room. So there we go. Now let's plug them in and see what each are doing. I'm hoping, fingers crossed, there's going to be different faults on each of them, and that means then I might have a chance of swapping parts around to find out what faulty things are, and then you never know, by the end of it we might get some of them working. Fingers crossed. Right, good news, all 4 are faulty and they have different faults ranging from no power to noisy. Also, one of them has a fan which is just moving around in jerks like that. So yeah, should be interesting. A few annoying things are that on a couple of them the top hinge is broken here, which isn't going to be a repair unless I can get a replacement. It's not going to be a repair that will ever work well just by gluing that, because they need to be quite strong, because even when they're intact you can see that they broke, because I think when people open them, they kind of, instead of opening them from here like that, they probably just, like, you know, grab the top and open it, and in doing that you're putting a lot of force down. Or maybe even if you just whack them here, it will break the hinge. So probably a bit of a design fault. Anyway, let's start on this one here. This has no power whatsoever. I've got it plugged in. You have 2 options. You've got mains going into it, and you also have a 12-volt lead here that has a cigarette lighter car charger thing on the back, so you can run it from a camper van or a car. When I move this here, there's no green light on here and there's nothing happening. So let's start on this one. Good news is none of them have been opened before, because you've got to prise open these things here, and when you prise open the corners they actually damage it a little bit. So it looks like I'm the first one in here, which is always a winner. So I'm just going to prise in hard here and lift up. But it does cause damage, but not much. You can flatten that down again. Now obviously I'm unplugged, but there still could be charge in the power supply on the inside. I'm putting a lot of force down on here to get in here. And now we just need to get a Phillips screwdriver in there. And now we just need to prise out this whole top lid here. There we go. We are in, so this is the power supply here. So now let's see what's going on with this power supply. Just going to gently prise the lid off if I can. Oh, it looks like there's a bit of solder there, doesn't there? Interesting. Yeah, splatter solder. Am I going to be able to take this out? Yes, I am. Right, and we have, that's strange, there's a little bit of, I'm being very careful here, this is a low voltage side of the power supply. There's a little bit of wire here. Oh no, that's a bit of plastic. So that's probably from, oh, it's from here. So by prising it out there, you can see that this, the clip, there's a clip here, but no longer here. Right, I'm going to use an insulated screwdriver for this. Let's take out this power supply, because that big cap there, this one, still might have voltage in it. Now if you were to probe around in here with it plugged in or even unplugged, you could kill yourself, you could get electrocuted. So don't copy what you see in these videos here. I'm doing this carefully, but there's still a chance that I could touch that big cap. There we go. I'm going to go straight onto that cap there and see if there's anything in it. Look at that. 313 volts. That's why you've got to be so careful. 300, even after all this time that's been unplugged, there's still over 300 volts in it. So if I was to touch that, that wouldn't be good news. Well, I'm going to drain that and turn that energy into heat. So there's the resistors in here, and what that will do is it will turn the energy, the 300 volts, into heat through the resistors. I'm just going to hold that on there for a good 10 seconds. Now let's see if there's anything there. And now if you have a look, after holding it on for 10 seconds, we're now down to 3 volts. And climbing, interestingly. Right, okay. So that is safe to now work on. So what we got going on? Got the mains coming in here. We got the fan going up here. So it's obviously had some use. I think we need to see if there's any, if this power supply is outputting anything. So although I've just drained it down, I'm going to plug it in again now, and I'm going to test the output here. Yeah. So I presume this is going to be running off 12 volts, the same as the car charger thing. And I can't see any burning or anything like that. It all looks a-okay. We know that the fuse in this side of the circuit is okay because we had voltage in the capacitor. Let's check here, because if we've got 12 volts here, it means the problem's elsewhere. If we haven't got 12 volts here, it means the problem's with the power supply. So I'm going to plug it in again now. But obviously, I'm going to keep my hands well away from anything here because I could get electrocuted. I'm purely going to test the output here with my multimeter. Right, so I'm plugged in there now, and I am turned on to max. Let's see if we have anything coming out. No, we don't. So it's a power supply issue. So we've got 330 volts there at the cap. Right, okay. Well, what I'm going to do here is I'm going to move on to another one. Because, let me just drain, I'm unplugged now. Let me just drain that cap, because that power supply, it looks good. It's going to take me a long time to fault find that. So let's get one of the other ones working, and then I can use that as a reference to hopefully fix this one. Now there is a chance that there's a short on this side here that maybe is stopping the output. So first of all, I'm just going to measure for voltage here on DC. Right, again, we're safe to work on. Yep, 2.6 volts. Now, let's go to ohms. Let's see if we have anything here. 20 ohms. I don't think that would be enough to stop it from working. That's probably normal. Yeah, 20 ohms, yeah. Right, okay, let's shelve this one for the moment, and we'll come back to this one when hopefully we have one of the others working, because it'd be so much easier to work on.
Don't you just love switch mode power supplies? They're so simple to work on. One thing I do love though is my PCBWay sponsorships.
PCBWay have over a decade experience in the PCB industry. They have state-of-the-art manufacturing facilities, and they use the latest technology to produce high-quality PCBs that meet your specification. At PCBWay, they have a range of services including PCB prototyping, PCB assembly, flexible PCBs, high-density PCBs, CNC machining, and 3D printing. And if you're heading over to PCBWay.com and go to Shared Projects, you will find a section where it says Projects of the Week. You can find some interesting stuff on there, and also there's PCBWay videos where you can learn more about their services and activities.
So a massive thank you to PCBWay for sponsoring the My Mate Vince channel. Now let's move on to the next Xbox fridge.
Now watch this one, the fan just kind of like pulses round ever so slightly. So now if I turn it on, oh, it is on already. Right, so you can see the light there. doing that, and the fan is boom, boom, boom. Not right, is it? But the very fact it's pulsing. I think this is going to be another power supply issue. Also, this is I can't actually switch it. The switch is broken. So I'm unplugged now. The switch is wobbling all over the place. Yeah, I've got a feeling this is also going to be power supply related. So I don't think we're going to have many fixes out of this job lot, unfortunately. And again, a lump of solder. What on earth's going on? How bizarre is that? A lump of solder on both power supplies. Really, really odd. Right, what's going on here? This is all... Oh, that switch is broken. Okay, well you can see here the switch has come away from the board. But again, it... well, I suppose we have to sort that to begin with, don't we? Now, is it going to be anything live on here? No, this is all on the low voltage because the live goes in here, and this is low voltage here. Let's just see if I can get this switch working. So annoyingly, we have screws, but underneath the sticker here, so I'm going to have to pop the sticker out.
So with the switch here, it's purely that the covers come away from the actual inside of the switch. So the metal switch just needs putting back on, and then the tabs at the bottom folding back round. No big deal. Bit of a design fault because you see the whole little board here is being held on by the front of the switch. While if the board was being held on, then the front of the switch would be sandwiched to the actual case of the Xbox fridge. So you're asking a lot for that little switch to hold onto that board. If you use that switch with a bit of vigor and with your thumb pushed in a bit too far, all you're going to do is push that board straight out. Bit of a design fault again, I think. Anyway, if you're wondering how these things work, they're not like a normal fridge. This is working similar to that dehumidifier that I did. This will have a little Peltier plating. So when you put voltage into a Peltier plate, one side gets extremely hot and one side gets extremely cold. And then they're using the fan to push the cold air into the actual Xbox fridge. And then the hot air is being exhausted out of the top of the Xbox fridge. So it's an item which is never going to be efficient whatsoever, and also because of the fan constantly running, I think it's going to be quite noisy. So this item really is more for novelty product rather than a functional product, even though it will cool things down. You're going to spend a lot of electricity cooling those things down compared to popping it in your normal fridge in your kitchen.
Well, I think that's okay. Really, the board should have some sort of mounting on, and then the board should be screwed in, and then the switch is always going to be under pressure on here, you see. But as it is, the switch is screwed in, so if you were to push this in too far or give it a whack, all that's going to happen is you're going to push that board right through. So not really the best. Right, let's again get into here. Now, is there a way I can do this without breaking them, I wonder? So I've got a feeling the tabs are just going to keep on breaking. Or is it just luck? No, they broke again there. So I would have to, I think you've got to push in. I think you've got to push in the sides, but there's not much give.
So I take out the power supply just like the last time, and I measure the big cap, and just like last time there's still high voltage in there, but this time there's only 100-ish volts. So with this one we can see that it's pulsing. So the power supply must be doing something, but obviously it's not right. So what I do on this one is I unsolder the two wires going out, the red and the black wire, the 12 volt wires, and I measure the power supply when I plug it in back into the mains, and sure enough it's got a stable 12 volts. So when the power supply is not under load, it gives out a nice 12 volt supply. But yet when you connect it up, which I'll show you in a few minutes, it's all over the place. In fact, it's moving so quick the multimeter can't keep up with it. So I'm going to use the oscilloscope to show you. But what I also did is I put 12 volts in via my bench power supply, and sure enough the fridge comes to life. So if you were to use this via a car or a camper van or something like this with the 12 volt lead, then it would work fine because 12 volts will actually run the fridge. So what I'm now going to show you is the wires connected back up, the fan pulsing, and the output on an oscilloscope, because I think it's quite interesting because you can fully see the pulses of 12 volts.
That's all over the place, isn't it? So when the power supply is under load, it can't cope. and my meter's not quick enough to actually read the signal. I'll tell you what we'll do. Let's get the scope on that. Let's see if my scope's quick enough. I'm just going to unplug it for the moment. Right, we're on 1 volt there. Let's see what it's doing now. Plugged in now. Oh yeah, look at that big peak. Right, let's change this to 2 volts. And whilst you're watching this lovely little scope, let's give a quick shout out to the My Mate Kids Massive. The members this month are KipDigital.com, Kip Hakes, Max Rokatansky, Having Fun Repairs, Chris Seal, Felipe at MrKeeps.com, DJ VG, Pigsy, Robert from Timsy's Auto Air, Daniel Watson, Zeke C, Anthony Dean, Bazza2, Russ Melanson, Ellis Garbett, Gaspar Heller, Richard Bergland, Jacob Colpin, Matt Rawlins, and Soul Reaver 555. That was in record time. Right, okay. Well, nice to see the scope can pick it up anyway. Oh, it's nice to get a little bit of scope action on in one of my videos. I still intend to get a decent scope and learn all about them, but my intentions can often take years. I've been meaning for 3 years to get a 3D printer, but guess what, guys? At long last, I've got myself one. Yes, it's a faulty one. Haven't even unpacked it yet, and it's only a cheap one. It's an Ender 3 Pro. But if I dip my toes in the water with it and then like it, then I can always buy a better one at a later stage. Just like the Spot Welder. I've dipped my toes in the water with that. Well, somebody else dipped them for me, Robert from Timsy's Auto Air. But now I love it, and I'll definitely buy another one. So, yeah, quite good. Anyway, let's get the third no power one up on the bench, and let's see what's going on. Just like the first one, this one here still is discoloured in the middle. So it looks like there's some hot spot going on in the middle of these power supplies. I'll show you more later on in the video. But yeah, it's so far a little bit unlucky. So both of them both have power supply issues. So yeah, I'm not sure how many we're going to get working at the end of this, but this is real life. And if I can get to the bottom of it, then if I've got ones that's got 2 power supply faults, then 2 out of 4 so far, then you know worldwide there's going to be thousands of these that have gone faulty from power supplies. So if I can find what the problem is, potentially it could save a lot of people a lot of time for those that do like messing with power supplies. And I appreciate not many people do mess with a switch mode power supply, because this could be just run from 12 volts. So you could just get an external thing, wire it up and just run it from 12 volts, couldn't you? Do you know what I mean? Just get an external power supply brick and run it from that. So there's other ways of doing it, but it's always nice, especially for the videos as well, to actually try to prove what the fault is. And hopefully, bit by bit, going through this, we might be able to prove something. Anyway, on to the third one. And this is the third one. And again, no power on this one. So I'll just quickly take this one apart. I'm not going to film it. I'll just show you whether or not it's the power supply again. Haha, no way, it came off really easy. Look, wow, the pinching really does work. Look, check this out. That's on there, yeah? And before I was pricing up from here on the low voltage side, but obviously I've got to be careful. We know there's going to be a charge capacitor in here, but look, pinch top here and bottom, squeeze. Look how easy it comes off. Results. Right, well, we've learned something from the video. Right, another very burnt looking board. Look at it. It's completely discoloured. See all around here? The middle, all around that transformer area. Anyway, let's see now what it's doing. First of all, we'll see we've got voltage in the capacitor. I think this is going to be rinse and repeat of last time. Yes, we have 328 volts. And now we'll plug it in, and I'm sure we're not going to have any output on the 12 volt. Plugged in now, turned on, and let's see what we have here. Nothing, completely dead again. So that's 3 boards, or 2 boards with the exact same fault, and 1 board with a power supply that doesn't appear to be providing what it needs to provide. So it looks like we've got 3 power supply issues at this moment in time. Well, let's take apart the working board, take out the power supply off that, and compare them to these 3, and hopefully we might be able to see what's going on. I've got a feeling this is going to go on for hours upon hours.
Yep, another Vince video that goes on for hours and hours. I'm blessed, what can I say? So I was expecting slightly more varied thoughts. I was thinking maybe a fan not working or a switch not working. Yes, I did have a switch not working, but behind the switch not working was another power supply not working. Woohoo! Aren't I so lucky? Anyway, let me introduce to you the fourth one. This one has got power, and whether or not it's working as a fridge, I don't know, but it's not cutting out. So surely the power supply on this should be working just fine. In which case then, brilliant news. We can compare between the good power supply and these 3 faulty power supplies, so we've got something to go on. So I introduce to you the fourth and final Xbox fridge. Will this be the one that fixes all the others?
Right, now this is the working one, but it's a bit noisy. Also, I don't actually know if it's acting up, if it's actually going cool or not, but it's certainly, the light comes on here, the fan kicks in, it's quite noisy, and little things like, if you have a look at this button here, oh no, this button here, which is the mimicking the eject button for the disc, the lights are coming on up here, so when I turn that off, lights go off, so that's working, and this button here is controlled with the sync button, the fake sync button down here. So can you see, studio lights are too bright, you see. There you go, you see off, on, off, on. So this appears to be doing what it needs to do. But I'm not sure whether the Peltier thing, because this is working via a Peltier, the same as the Peltier plate, the same as the dehumidifier. Can't really feel it getting very cold at this moment in time. But I have only just turned it on. Good news is that the power supply does work. Does it work on Eco? Yes, it does. Yeah, okay. So that's good. Maybe because I bought 4 of them that the seller gave me one that he thinks is working okay. So let's get this board out, and now we can start comparing between everything. Be interesting to see when I get this board out whether, because right now this one was working, whether this will also store 330 volts in the capacitor, because that could be a clue as to the problem. Let's just see if the pinch was a fluke. No, it wasn't. It's amazing what knowledge gives you, isn't it? Now, this one here is not burnt. Interestingly, this power supply on top is nothing like the other ones. There's no burning. So the other ones is to do with overheating. You see I'm touching the low voltage side. Right, let's see. Oh, this is so much different. This power supply is unrecognisable compared to the others. The others are all brown round here. Right, let's see. I've got a feeling that this is going to be a real common problem. Yeah, and we're down to 10 volts. Sorry, 20 volts. Well, with 20 volts, I'm happy just to short that. There you go, see that little spark? Right, down to 1 volt. Okay, I'm going to plug in just to make sure it definitely is outputting 12 volts. So the very fact that the other ones are not draining the capacitors, some of you guys will know the reason for that. Well, I'm turning it on here now and I'm plugging it in. Nothing's going to short anywhere. 1 second, I just want to get this so I can actually measure. Right, so I can measure across them there. Plugging it in now. And it's come to life. Let's see if I can measure 12 volts while it's working. 12 volts. Fine. Just want to go on to the DC jack in. So yeah, see that's 12 volts. So if you had it plugged into mains and your car at the same time, you're going to be putting 12 volts into the car, aren't you? That shouldn't cause a problem though, should it? Because you can charge your car through the cigarette lighters, can't you? 12 volt, jack things. Right, okay. Let's go on to low power mode, Eco. I want to see what that's outputting. Is it still 12? Yeah, it is, yeah. So I'm going to unsolder this board and then I'm going to use my multimeter and I'm going to see what the differences are between this and the other 3 boards. Wouldn't it be great if we could pinpoint it to one component? So this is the good one here because it all looks perfectly nice and clean. Now this one is FG for Flash Gordon. This is the one that keeps on flashing, and then these 2 here are completely dead. Now have a close look at them Not this one, but can you see one of them does actually look different than the others? So you can pause the video if you want. Now I'll give you a clue, I'm not talking about the burning. Obviously these three here, you can all see that they're discoloured compared to this one. There's something else. Right now, if you said it was something on Flash Gordon here, you'd be correct. So now, let me just angle it differently and now see if you can see the difference between these two boards. I've given it away there by touching it. Can you see that on this cap here it's ever so slightly bulged, and these are the output caps. So it would make sense that it's not giving a clean 12 volts. Look at that one there. Can you see how much it's bulged? Yeah? So this one's flat, but that is certainly not flat. Look at it compared to the two other dead boards. Completely flat and completely flat. And the good board, completely flat. But that certainly is not completely flat. So I think Flash Gordon has an actual different fault than the other two. I think if we change out that cap there, we'll find that it's going to be okay. So this is a 1000 microfarad at 25 volts. I wonder if I've got any of them. Now I've got 1000 microfarad at 16 volts. Oh, annoying. Let me see in my other pack.
So it's always nice when we see a bulging cap, especially when it's an output capacitor, because now it makes complete sense to me. That's why the output was unstable, because the capacitor was causing problems in the circuit. Annoyingly, I haven't got a spare capacitor at that value. I have since bought them, but not at this time when I was filming. So what I've done is I've taken two off another power supply purely to act as a donor, and then if I get it working I can always buy some for that one there. When I take the caps out, I do test them with my meter for capacitance, and the bulge one is well out. It's like 300 or 400 microfarad instead of 1000s. And I also test it for ESR. Strange thing is, it's not giving me any reading on the ESR meter. And I've had that once recently as well. So it's like it's not even acting as a capacitor, which is strange. I thought it would give me a reading that shows that it's acting like a resistor rather than a capacitor. But no, it was just the same as not having anything plugged in at all. So I was sure that this was the fault. So I took two off another board, soldered them in, and then soldered them into one of the Xbox fridges. I even got a wet wipe out, started wiping up the fan and stuff, thinking it was going to be fixed. I put the lid back on it, but I didn't put the screws in. And then this happens when I plugged it all back in.
Right, I'll screw it up in a little while. Let's see if it's actually working. Come on now, be good. Be good to me. In here. You what? No way. No way. It's doing the same problem. I was sure that was going to fix it. What is going on? The fan's going around more though. Right, let's turn the lights off. See if that gives it a little bit more power. No way. Flash Gordon is still Flashing Gordon. Oh, what? This is not going to be good to me, is it? So there's something on these three boards here that's not on this board here, which is faulty, and I bet all three of them has got the same fault. So we've got to find out what that is.
So I've got my meter set in diode mode here, and I'm going to be putting the red lead to the negative of the capacitor, and then I'm just going to be probing different parts of the board to see what's different. For example, I've really noticed on this little 6-pin IC that if I go onto the middle pin here on the right hand side, it's 0.59, but look on this board here, it's different. I mean, that's a lot different, yeah? But then if we were to go to this diode here, that's 0.61, and this diode, I wouldn't be bothered by that, you see, because there's not much difference there. But that one is very much different. But then, when I go onto this board, it's the same as the good board. Yeah, 0.59. So the boards may have different faults. 0.59, let's try, is this Flash Gordon up here? Yeah, let's try this one. 0.59. But you can already see that this is much different. So maybe in this instance that chip's failed, but maybe on these other boards it might be like the switching transistor or something. In fact, let's see if we can get a reading off them. So if I go here to here, right, so that's going to be ground. Yeah, because you see that's the same as the leads being together. 0.55 and 0.70. 0.55 and nearly 0.70, so I don't think that's faulty there. 0.55, nearly 0.70. 0.55. Yeah, so I think just from that those transistors may be okay. So that's what I'm going to do. I'm just going to go through different things, see if I can find anything. When I come to this side of the board, the secondary side, the lower voltage side, then I'm going to have to be using the negative from the capacitors here. Also, I need to put that capacitor back into this one because otherwise we're going to get a bad reading, aren't we? I haven't got one to put in. What I'll do is I'll put in my 16 volt one instead. But on this one here, I can just go onto the negative rail here. And then, for example, I can test this one here, this other transistor thing on the way out. So we've got 0.27. And that looks like, so they both look like grounds, and then 0.27. And if I was to go onto the good one, ground, ground in the middle, 0.27, yeah? So that's all I'm going to do. I'm going to go across them, see if I can see any differences. So I test various different components, and the massive big cap does actually test different for ESR between the good ones and the bad ones, but I do swap one of them out and it doesn't make any difference. So although I suppose the cap's deteriorating because of the heat, it's not the actual cause of the problem on the bad boards. I think the 6-pin little switching IC is going to be to blame for at least one of them, because we are getting a different diode test reading. So let's remove the chip and put the good chip on from the good board and see if it makes any difference. Now the reason I know this is to do with the switching is because if you have a look, can you see here, it goes through the resistor up to this transistory type thing, you know, this massive thing with the heatsink, and the other leg goes around here through there, through this resistor to, I think, that leg there, and that then goes up to the transformer, the middle one there. So yeah, I'm going to pop this off and see what it does. Now, do these have glue underneath them? Are they going to be hard to take off, I wonder? Have they been wave soldered? That looks like it might have. Not sure, just in the middle there. Don't know about it, I'm not sure. We'll see how easy it comes off. Let's get some flux, we'll add some hot air to it, and let's take it off. See, something's got warm, and it's failed because of constant heat, I think. So I just think that with these, the more they're used, it looks like they're gonna fail, because all these ones have red hot boards, unless, of course, it's something to do with maybe the transformer, because the heat does all seem to be around that area. Now I'm going to try out these fancy new tweezers here. I actually seen them on, it was either a Coda video or a Coda live stream, I can't remember. But he mentioned them and I thought, oh, they look fancy and nice. Because I know when it comes to, like, when I mess around with watches occasionally, I did invest in some 20-something pound tweezers, and it just makes picking up screws and stuff so much easier. So maybe by investing in tweezers that are not just like, you know, a pack of 10 for a few pounds. I think these were like a few pound each. I can't remember how much they were, but maybe it'd be nicer to be able to lift off things. Feels like I haven't used hot air in ages. There we go, that came off lovely and easy. Now I'm going to get my good board and I'm going to take it straight off the good board and pop it on here. Sorry, you didn't see me take it off the good board there, it was just out of shot, apologies. Whoops. Right, so we've got a different capacitor in here which didn't make any difference, and now we've put a different chip on here, which I think is to do with the chip, but I don't know. Right, let's plug it in, make sure there's no metal around the place, and let's see what it does. Hopefully, well, the chip's the same because it's got the same markings on it. Plugging it in now. I can hear a noise. The hell? Weird. Right, let's turn this on. I think this is going to work. There we go. Result is the chip. It's the chip. Fantastic. Excellent. It's the chip. 11.6 volts. Right. I'm going to turn it off because we haven't got any load connected to it. Interestingly, I can hear like a coming from it. So maybe this might be another pulsing one. But, oh, also, let's see now if we've got like 60 volts on the cap rather than, because I always had 300 volts on that cap, didn't I? 330. See what we got now. No, I've still got that. Ah, do you know what? That says to me that this is not going to work. I think this is going to be a pulsing one. But I won't know until I connect it. Because the working one didn't do that, did it? Okay, but the good news is we've proved that little chip anyway, right now. Whether or not there's other stuff wrong, I'm not too sure. But before we had nothing here, and now we've got something here. So let's drain it down. I'm going to connect it up to the actual fridge and see if we have anything. That's interesting. I suppose the chip's doing a lot of work, isn't it? It's telling those transistors when to turn on, turn off, turn on, turn off, turn on, turn off. So, yeah. And maybe if this area gets hot, maybe that chip doesn't cope with heat very well. Right, I've soldered it in upside down just to make it easy for myself because I'm going to have to be taking that chip out to put it into other boards anyway because it's the only one good chip, I think. Let's see though if this is going to come to life or is it going to pulse. So, plugged it in now. I can still hear it clicking. Pulsing, look at that. But this is pulsing even faster. How bizarre. Okay, so we know that that little 6-pin IC is responsible for doing part of the working. Okay, so we know that the 6-pin IC is responsible for at least getting it to work, but now we need to find out why it is pulsing. So at this moment in time, we have one good Xbox, we have two that are completely dead, and we have one that is pulsing. So it's safe to assume, hopefully, that the two that are dead are to do with the 6-pin IC, but the one that is pulsing, what's causing that? And the two that are dead, one of them is now pulsing. So maybe with the other dead one, that will also pulse as well if the 6-pin IC was changed. So right now, we need to find out what's causing the pulsing. Now in real life, I must have spent about another 2 hours on this, swapping out the big filter caps, swapping out the little switching transistor, even swapping out the rectifier diode on the output of it. I try to, oh, and also the optocouplers. I test the optocouplers as well. And basically, I can't find anything wrong. Every time I swap something with a known good board, it keeps on pulsing, as you can see in this little snippet here. Anyway, eventually, I come to this next part of the video where I think we're about to make some progress. Well, I think I've bit off more than I can chew trying to get all these done in the one video. But anyway, I've been going through comparing, and all of the resistors on this side here, all around here, seem to be okay. The ones down here seem to be okay. And then I noticed that there was a sneaky little capacitor just up inside here. Now on the good board, it's measuring 1.3 on the ESR. And on this one here, it's not measuring anything. Nothing at all. So, could it be that? Maybe. Because maybe this is supplying power, well I know it's supplying power to the little IC down here, because it's on that path that feeds that one there. So let's put the good one in and see what it does.
Right now, I am actually hopeful. I think this is going to fix it, because I think it's the power supply going to that little chip is not stable, and that's why it's cutting in and out. So here goes. Come on now. Plug it in now. Come on now. Yes, yes, yes! At long last. Fantastic. Brilliant. Tiny, tiny little cap. The smallest one off the lot. Where's it gone? This. What is it? It is a 10 microfarad 50 volts. And I am going to have them, I think. Let's see here. 10 microfarad 50 volts. Wow, just goes to show you. So I suppose the heat built up in this area massively, and it probably burnt the electrolyte out of this, out of the cap maybe. Well, mind you, there's nothing on the board, and it hasn't vented. But whatever it is, it's not happy. Wow. Okay. Lights. Ah, beautiful, beautiful, beautiful. And this little thing's here now. Ah, fantastic. Okay. Well, I took a long time to get there. See, everybody always says to change the capacitors first, but in my experience, I haven't had much luck with changing capacitors out. Well, that's a lie. I have, but other people just seem to change capacitors and everything starts working. But yeah, in this case, I think it was all just that one capacitor. I know we did have a bulging capacitor on the output, but I don't think that was why it wasn't working. Result, okay. Brilliant. Whether it's getting cold or not, I don't know. Remember, these may have other faults, but I might not necessarily do them in this one here now. Right, okay, we need to start putting things back together. So, I think the other one, which is also pulsing, will be that capacitor as well, hopefully. And it looks like only one of the chips is at fault, I think. So at long last, after many, many, many hours, I've managed to find out what was wrong with them. So we had 4 Xbox fridges, and one of them was working from the beginning. A little bit noisy, but they're all noisy anyway. I think that's just what they are. So with the other 3, we had one that was working but pulsing. So the fan was just kicking round, and the other 2 were completely dead. So this is the outcome of the video. The one that was working but pulsing was all to do with that tiny little capacitor, the 50 volt 10 microfarad. That's what stopped that one from working. Yes, it also had a bulge on the output capacitor, but the main fault was that little capacitor. Once that got changed out, it started to work. Now, the other 2 were completely dead. They were to do with this little 6-pin IC that we need to talk about when I finish up the video. Also, one of them had that little capacitor fail as well. So when I changed out the chip, it then started to pulse. And that was to do with that little 10 microfarad 50 volt capacitor as well. So basically, if I wanted to get all 4 fixed, what I would need is, I would need 2 of these ICs, and I would need 2 of the capacitors. Capacitors are not a problem. They're only pennies, and I've already got loads of them. The problem is I can't find out what chip I need to put in, but I'll talk about that in a few minutes, and maybe the viewers can help me out. So right now, out of 4 of them, I've got 2 of them that are working perfectly, and what I did is I mixed and matched things until I got 2 of them working. Because, for example, on this one here, you can see I've taken the hinges off both of them. So with these hinges, they're not plastic. Fair play, they are some kind of metal. But I suppose what's happening is people are kind of putting their feet up and they're resting them on these things here because they're the kind of perfect height to rest your feet on. And in doing that, you're putting too much pressure on the top hinge and then it's breaking down. That's what I think's happening. So yeah, I can only get 2 working at this time, but I can get the other 2 working if I get 2 more of these chips. The problem is though that I'm not going to be able to get the hinges. Maybe they could be something that could be 3D printed, but they're metal to begin with, and you're then replacing it with plastic. They probably won't be very strong. So let's finish up the video now, and I want to show 2 of them working, and then I want to talk about this annoying little 6-pin IC. These have been on for about half an hour, maybe longer actually. Yeah, probably about 45 minutes. So yeah, they're quite noisy, but I don't think that's a fault. I just think that's what they are. So I've got a temperature probe inside this one, so we'll measure that in a minute. Just see if this feels cold. Definitely, yeah, 100%. That feels cold. That would keep your drinks cold. So I don't know what the temperature in this house is going to be right now. I presume 20 something. It's quite warm because it's you know, coming. We've had good weather in the UK. Let's see what it's going to be in here. You ready? There you go. 13.3. 13.3 Celsius. So 100%. It's a lot warmer than 13.3. You can see it's going up now as I'm pulling it out. So there we go. It's working. I just can't see how anybody would put up with that noise. The lights and stuff are nice, so I get that when you turn it off at the back. I get that you could still have it like this with the lights on and use it for the USB port down here. But yeah, I don't know. I think they're a bit of a bad design, if I'm honest with you. Good idea, but I don't think the implementation of it really works. But that's just my opinion. Obviously, everybody's entitled to their opinion. I'm sure lots of people love it. Now, bad news on the chip. This is happening more and more and more and more. It doesn't exist. 33134 is what's written on the chip. I thought on one of them it might be 33114. Not too sure about that. But anyway, the two that I've got out here and here, I've looked through the microscope and they're definitely 33134. That doesn't bring anything up on Google. So what I did is, I looked at the board and I worked out what's what. So the dot's down here, so that's going to be pin 1, and that's the ground, 100% that's the ground. That pin's going off to the optocoupler. That one is not connected, it's not going anywhere. This middle one is going to the positive of the replaced capacitor. You know, the capacitors are kept replacing. So that's obviously the power input going into it. And then this one is going to the gate of the N-channel MOSFET, and this one is going to the source of the N-channel MOSFET, the gate and the source. You know, that N-channel MOSFET that had the big heat sink on it, and it's going to be called something along the lines of PWM, Pulse Width Modulation Controller Power IC, or Switch Mode Power Supply Power IC, something like that. So there's loads of 6-pin ones there, loads and loads and loads out there. But I don't know which one to choose because they all vary slightly. This one is available on eBay, this LD7537, but it's over £5 UK for one. Yet you can get 10 of them from China for £4. So if everybody thinks that that will be a goer, then I'll go for that. These are other ones that look like they could possibly be suitable, but I really don't know because they're. It's all just so confusing. You know, I just don't understand it, and that's the problem. Messing with power supplies like this, obviously it can be very dangerous if you put in the wrong thing. But I presume if all it's doing is switching this MOSFET here, then maybe loads of them will do the same job. You know, you've got your optocoupler. I've looked at all these ones here have the same pin out from what I can see as here. There's loads of other ones with a different pin out. So there's loads of these 6-pin ICs, but these ones have the same pin out from what I can see. So yeah, I can do a revisit one on this if you guys know what that chip is. I mean, ideally, I want to put the same one in, but if you think that maybe this one or this one will fit and work, then I'll do a revisit video on it, just to you know, get them in from China. Useful to have spares anyway, and then yeah, I'll do a revisit. But it's a bit of a shame how it just seems to be happening more and more, where the ICs have markings on that bear no resemblance to anything on Google, and you can't fix the items, which is a massive shame. So yeah, I think there was definitely value in this video, because if yours is doing that pulsing thing, you now know it's going to be something to do with that capacitor, and if yours is dead, I think it's a pretty good chance it's going to be that 6-pin IC. So going into the future, I can see all of these failing eventually, in which case then at least they are going to be repairable. For how long, who knows. Right, this next part of the video now was filmed after I finished up the video, but just in case I didn't make it clear, because I'm not sure if I did, the one on the left hand side is working as a fridge, meaning it's on max at the back, and the fan is operating. So when the fan's operating, it's circulating air. The one on the right is not on at the back, but it's still plugged into the mains because the lights work in here and the lights work in here, and you can use it as a USB to charge something. And it's interesting to see that when it's working as a fridge, it remains relatively cold because the fan's circulating the air. When it's not working as a fridge and it's off at the back, but it's still plugged into the mains and the lights are on, a lot of heat is being generated in this area. Check it out. Quick bit added on to the end of the video. I think I might know why they're failing. When they're on, you can feel hot air coming out of here, but the back feels relatively cool. You can feel heat, but because the fan's blowing, it's cooling it. But when they're off, but yet you have the lights on here, which I had on while I was chatting away. The back of this one now is warm in this area, as in warm, like a radiator warm. So yeah, I think that's why they're failing. I think when people don't want the noise on, so they're having it on like this because it looks nice, and I think it's burning through there because there's no circulation. So if they were on all the time, there's a massive difference between here and here. I could get the temperature probe out, but it's going to be too slow to react, I think. So let's have a little looky. Let's put it on here to begin with. Well, no, it's just going to take it off my finger, isn't it? I'll get back when it's settled. Right, it seems to have slowed down at around 28 degrees Celsius. So it's 28.1, but it's really slowed down now. So let's bring it over to here, put it on the same one there, the third one along, and let's see if it grows more. So this is the one with the fan blowing, yeah? I've got this one on at the moment, but this one I've got no fan on. And you can see already that it's starting to grow. Look at that. So that's why they're getting so hot, because you really need the fan on to keep the air circulating. So just by having the lights on, the power supply is working, it's providing power, but it must be too enclosed. There you go, you can see now that it is much higher than the other side there, and it still appears to be climbing. So I think that's probably why these ones are burning out here. What could they do about it? Well, maybe they could wrap it all in metal to do a heat sink away, you know, to get that heat away from it. Is that if you look at a laptop power supply, there's no air, there's no fans in them, but yet they operate for hours on end, and I think it's because they have massive lumps of metal around the place to take the heat away. Well, with this one here, there is no metal, is there? It's a plastic casing, there's not one bit of metal inside. So that's it, there we go, you can see now. Interesting, so I think we've learned a lot on that video there. If you enjoyed it, give it a massive thumbs up, and I will see you all very soon. Take care, everyone.